this video, the third video on trigonometric identities, we're going to look at some proofs using the identities we've introduced in the previous two videos. Let's just quickly remind ourselves of these. So we had sine squared x plus cos squared x equals 1, very common identity. And then we had sine of x plus y, so when you have two numbers inside the sign that you're adding up, we said that this is equal to sine x cos y plus or minus cos x sine y. So it depends. If you have a plus in the sign, then it's a plus on the right hand side. If you have a minus in the sign on the left hand side, then it's a minus on the right hand side. And then also we had cos of x plus or minus y is equal to cos x cos y minus or plus sine x sine y. So if you have a plus on the left hand side, you have a minus on the right hand side, and vice versa. That's why we have the minus and plus in the opposite order on the right hand side to what we have on the left hand side. So we're going to keep these here and we're going to use them to solve two examples. So prove the following. A, cos 2x equals 1 minus 2 sine squared x. And B, sine 3x equals 3 sine x minus 4 sine cubed x. So they look a bit complicated. They're not too bad. We just need to make sure we use these identities. So let's start with A, cos 2x. Well, if we're going to use any of these identities, it looks like we should use the third one since it involves cos. And we can use it if we write cos 2x as cos x plus x. So we use the third identity here to rewrite this now, but we don't have x and y, we have x and x, so we just change all those y's to x's. And we end up with cos x times cos x, which is cos squared x, minus, since it's a plus in the cos, it's a minus, so minus sine x, which is sine squared x. So we have cos squared x minus sine squared x. Now, remember, if you look at question A, we're trying to get to 1 minus 2 sine squared x, so we don't want a cos squared. At the moment we've got a cos squared and a sine squared, but the answer only has sine squareds, so let's try and get rid of this cos squared. We do that using the first identity. If sine squared x plus cos squared x equals 1, then we could rearrange this to get that cos squared x equals 1 minus sine squared x. We just take that sine squared to the other side. So cos squared x is 1 minus sine squared x. Let's substitute that in, and we get 1 minus sine squared x minus sine squared x. So if at any point in this video you're a little confused, you can always rewind the video or pause it. Just make sure you understand each step. So we have 1 minus sine squared x minus sine squared x. That's just 1 minus 2 lots of sine squared x. So 1 minus 2 sine squared x, which is exactly what we wanted. So we're done, and we can now try B. So B, we start with sine 3x, and we try and show it's equal to this kind of long thing on the left hand side, 3 sine x minus 4 sine cubed x. Okay, how are we going to do that? Well, we do something similar. We write sine 3x as sine 2x plus x. This allows us to use our second identity, sine x plus y equals sine x cos y plus cos x sine y. But instead of x and y, we have x and 2x. So you can just change the y's to 2x's. And we plug in, and we end up with sine 2x cos x plus cos 2x sine x. So here I've just used the second identity. We want to continue to rewrite this. We want to get rid of these double angle terms, so we have a sine 2x and we have cos 2x. So we can do the exact same thing. We write sine 2x as sine x plus x, and this would give us sine x cos x plus cos x sine x, which is actually 2 sine x cos x. And then we're timesing that by cos x, because that is what we have in the first term. So make sure you understand this. I've just taken the first term, sine 2x cos x, I've looked at the sine 2x and I've rewritten it as 2 sine x cos x, using my second identity again to rewrite sine 2x as sine x plus x, sub that into the identity, and I get 2 sine x cos x. Try it yourself. And then you times that by cos x. And then the second term is cos 2x sine x. We already know what cos 2x is because we did it in part A. It's 1 minus 2 sine squared x. So I'm going to change that to 1 minus 2 sine squared x, and that's times by sine x. Now let's get rid of these brackets. So times the cos x by that bracket in the first term, 2 sine x cos x times cos x. And that just gives you 2 sine x cos squared x, because we have a cos x times a cos x. Times the sine x through the bracket in the second term, and you'll get 1 times sine x, which is sine x, and then you'll get minus 2 sine squared x times sine x, which is minus 2 sine cubed x. So you get plus sine x minus 2 sine cubed x. Okay, if you have a sine squared and you times it by sine, you get sine cubed. Just like if you have a squared and you times it by a, you get a cubed. So now we're getting close. If you look again at what we're trying to arrive at, we're trying to arrive at 3 sine x minus 4 sine cubed x. But we have a cos squared x in there, which is no good because we don't want any causes. Again, we only want sines because the answer only has sines in it. So we focus on trying to eliminate that cos squared, and we do it the exact same way we use the first identity to rewrite cos squared x as 1 minus sine squared x. So I have 2 sine x, and then I change the cos squared to 1 minus sine squared x, and then the rest stays the same. So I have plus sine x minus 2 sine cubed x. I once again just times this through the bracket, this 2 sine x. So times it by the 1 and I'll get 2 sine x. Times it by the minus sine squared x and I'll get minus 2 sine cubed x. Okay, so I'll keep the minus sign, I have the 2 there still, and then I have sine x times sine squared, which is sine cubed. So I have 2 sine x minus 2 sine cubed x when I get rid of this bracket. And I still have all the other stuff, so I've got the plus sine x minus 2 sine cubed x. So I know this seems sort of quite long-winded. These problems often are. It's not so bad, just make sure you write down every step, you know what you're doing, and you show clearly what you're doing. So now I'm just going to gather up like terms. So take the terms that have the same powers of sine in them. So I've got 2 sine x plus sine x, that's just 3 lots of sine x. And I've got minus 2 sine cubed x minus another 2 sine cubed x, that's minus 4 sine cubed x. So I've got 3 sine x minus 4 sine cubed x, which is exactly what I wanted. So it's quite a lot of writing, but just using these identities I have in the top left-hand box, I'm able to show this equality.